And greetings. Welcome to the Evidence and Reasons for the Christian Faith channel. I'm Salvador Cordova. Here we usually review evidence and reasons for the Christian faith. This is done because the Christian God has chosen not to be as obvious to our senses as the air we breathe. It says in Proverbs 25:2, it's the glory of God to conceal a matter. It is the glory of kings to search out a matter. And also that the kingdom of heaven is like treasure hidden in a field. Someone found it and then sold all he had and bought the field. And so to search out the existence of God requires effort. It is hidden just enough so that people wanting to find it can find evidence of God. And then also people that want nothing to do with God can close their eyes and turn away. It seems that's just the way God has decided to do business. So the mission of this channel is to provide information that will encourage seekers that have an inkling toward the Christian God to have their faith strengthened, to see evidence that he is indeed there and has acted in the universe. Tonight, I don't know that there's any point of tonight except just to teach a little bit of physics history. Sometimes in the course of professional creationism, actually most of the time in the course of doing professional creationism, we'll go down paths that we don't know if we're going to find anything. It's just like going out there in the field and saying, oh, I'm going to look for fossils. There's no guarantee you're going to find anything of interest. I have been in contact with Philip Dennis, who is probably the most well-trained and most accomplished young Earth creationist in the field of general and special relativity. Both he and I have some views that are at variance, that are opposition to some of the cosmologies of other young Earth creationists. I'd like to emphasize this is absolutely nothing personal. When it comes to matters of science, somewhat like theology, brothers in Christ can disagree on how to interpret the evidence. And so someone said SoundCloud. Let me know if my audio's not working, guys. I don't know if that was referring to me. So I was saying this is nothing personal, but it says in the book of Proverbs, correct a wise man and he'll love you, correct a fool and he'll hate you. And so if it says in the Bible that wise men can be corrected, that means they can be mistaken. A wise man can be mistaken. And so, sorry, that's obnoxious phone just kind of rang. A wise man can be mistaken. That means even the wisest young Earth creationists or creationists in general can be mistaken. They can be corrected. And I get corrected, and I try to love the people who correct me. And Mr. Jetty's been the most helpful in that. It's sometimes the reproof is a little hard, but I have to accept it. I have a responsibility if someone brings to my attention something that I said is wrong to try to correct it and make a retraction. And so both Dr. Dennis and I feel that young Earth cosmologies like Jason Lyle's one-way speed of light, what they call the asynchrony convention, and starlight in time are flawed. And I don't know how to more gently say it than that. I think they are mistaken, especially Jason Lyle's viewpoint, and that is nothing against him, although I will point out there is a creationist channel that insists that I'm wrong about Jason Lyle, and I'll just point out, well, I actually have a background in graduate studies of physics, so you can compare my qualifications with the qualifications of that other channel, which will not go named. I'm going to try to get this chat going. Unfortunately, let me see if I can't get the connection going until I'm actually streaming live. So that is a little bit of a challenge. So let me try to get this live chat going, and I'll get it a little larger. So let me test to see if I can get this, if I could try a pin. There, okay. So I got the pin showing up. Okay, so, and I like Pisaro's comment, one way. Let me point that out. It is a little harder to get if you'll indulge me. It is just a little harder to get some of the pinned comments up. It says, creation questions. You might want to take your criticism of anisotropy. That is a fair comment, but my understanding is Dr. Dennis has already done that, and Dr. Dennis is like 10 times more senior than I am. And I had interacted with Jason Lyle. I told him I was doing experiments that were related to one-way speed of light. He didn't bother responding. So, and I saw him in conventions. We said hi, and that's just been about it. So I don't know what to do about that. But I think the thing to do, as far as I'm concerned, is I can be responsible for my understanding of the science and how well I could teach it and communicate it. Taking it up with Dr. Lai at this point, I don't know, because some of this just looks so obvious. And I've run it by Dr. Dennis. He said, you're absolutely right, Sal. So let me just point out a few things. The velocity of an electron, as it increases, approaches near the speed of light, the electron will get quote-unquote heavier. That means its rest mass relative to the stationary lab frame increases. So if there's a one-way speed of light, one electron will be heavier, the other in the other direction will be lighter. Not only that, one will be faster, one will be slower. You ought to be able to clock the velocity of an electron when it arrives, from point A, goes from point A to B, and the time interval in between. There are other tests like synchronizing clocks, and I'm going to go over that. The Heffel-Keating experiment showed you can. It depends on the ability to bring clocks back together and compare them. And if you can move clocks at a very, very slow speed, you can maintain synchronization. I don't know why that's hard to understand. Even if you don't know the one-way speed of light, if you move the object slow enough, you could tell if there's been a a large difference in the one-way speed of light, because time dilation won't happen. Like, let's say light is moving infinitely fast in one direction. If you move that clock in the direction of that high light speed, it's not going to dilate. And if you move the other clock in the other direction, it's going to dilate a lot. You ought to be able to detect that, and we don't find that at all. So I have to work out the math of this, and I don't know why, you know, it's taken. I hate being the fall guy to call out other creationists, and I've gotten a lot of flack for it. I pointed out guys don't use the second law of thermodynamics, and now, you know, this thing with the asynchrony convention. So, you know, all I could say is that I can be responsible for teaching this like it would be taught at the undergrad and grad school level. I have an academic channel where I plan to do this, and Dr. Dennis and I are just going to be in communication, because both he and I feel, you know, rather than attack someone else's theory, the best way to go about this is just to teach basic relativity. And when people are more educated in the topic, they'll be equipped to decide for themselves. And, you know, I think that's probably the best way to go about this. People that are really interested in this can learn. We'll teach the textbook version, and then we'll compare it with, you know, various other ideas. We'll do calculations, and we'll go through experiments, and that's about all we could do. I feel if the young Earth community is better educated, we'll all be the better for it. Same for arguments in biology. I have, you know, I've tried to put some different perspectives on how biology should be viewed, how to criticize evolutionary biology. Dr. Sanford has insisted, and sometimes it's kind of difficult. He says, I don't want you publishing in creationist journals. I want you going to secular journals. And I'm just like, Dr. Sanford, you know, we're creationists. This is going to be really hard. He said, no, we're going to, you know, we're going to get a foothold in the secular world. And I'm pleased to announce our Springer Nature chapter is in a $1,500 book, and those books now are in university libraries. I'd like to think that these are like shining stars in a in the dark sky regarding evolutionary theory. We got away with being able to criticize evolutionary theory simply by quoting evolutionary biologists themselves. There's no reason that they should remove what we wrote, because we didn't cite creationist, pro-creationist literature. I mean, creationist literature. We cited literature of evolutionary biologists and mainstream stuff. So, you know, that the approach that we used was a little bit novel, and we think we're able to teach creationists a better way to argue some of their ideas. I published with Joe DeWeese on topoisomerases and post-translational modifications and K-modes algorithms and stuff. And we have a paper kind of under review now, and we're hoping and praying it gets through. So all this to say, you know, rather than directly trying to attack or confront others, you know, who've already been confronted, you know, I think maybe the way to sow peace is to just mind our own business, teach as well as we can. They are invited to confront us, and I'll leave it at that. If Jason Lyle wants to confront me, if he wants to confront Dr. Dennis, you know, the venue is open. We can have a discussion. We can compare notes, and if the other side doesn't want to interact, I will totally respect that. I will not accuse them of cowardice or whatever. There's just no need for that, okay? So, you know, I'm not trying to pick a fight. I'm really not. I've been in this long enough to know people will believe what they want to believe. Okay? I mean, I've been dealing with evolutionary biologists for 20 years. Okay? Um, I've given up on trying to just spend the rest of my life confronting them rather than gaining knowledge and then reaching out to people with my ideas. And so I've shared some of those. I mean, it's been a delight for me to share about topoisomerases with this group and then to see it then advertised by the Discovery Institute. I've been delighted to share Stairway to Life by Change Tan and Rob Stadler. You know, there's no need to go after other creationists and find ways to disagree with them. The way to advance the argument is just to review the physical evidence, the experiments, and the theory. And maybe we can all learn together and understand the discussion and correct one another. So let me look through the side chat and just give my my greetings. So Bread of Life, greetings. And Creation Questions, Patrick Alexander, greetings. Testament. And Paleologos, great to see you. Pizarro. And I'm just looking at that. Does your model correspond closer to Dr. Humphreys? No. And I think there's some observational evidence that doesn't agree with Dr. Humphreys. I'm sorry to say. And Russ, I call him Russ, Dr. Humphreys. I consider him a friend and someone I've confided in. But that is, so there are some models that he works on for Earth's magnetism that I think he's just spot on. And if he's not, he's really close. He's certainly better than the secular world. But the starlight in time is, I've been invited to try to communicate some of the problems with it. One of the experimental things I was looking for is, according to the starlight in time model, the farther we look out, we ought to see the galaxies spinning faster. So the higher redshift galaxies should be spinning faster. Because according to starlight in time, the distant galaxies are evolving, quote unquote. Time is flowing a lot faster out there than it is here. And if that's the case, we ought to see the galaxies spinning like crazy, and they're not. I also think in such case you would see them brighter. I actually did look at evidence of Doppler shift at the various parts of the disk. If the galaxy's tilted just the right way, you can take a Doppler measurement on the left side, so to speak, and then the right side, compare it. You can estimate the speed of the rotation. So if you look in the Wikipedia articles, they have the galaxy rotation curves. They're able to estimate the velocities of the galactic spin. According to starlight in time, I tried to point this out to Russ, it would seem to me that if the farther out the galaxies are, that they're evolving faster, they should also be rotating faster. We actually, my best look at the measurements available has been the opposite. The farther out we look, the slower the rotation is. Now, I need to mention this. This is one reason that, and I passed this on to Barry Setterfield. I said, you know, that is consistent. The observation that the more distant galaxies are rotating slower, the higher the redshift, is consistent with speed of light decay. And I also gave him some data points with globular clusters, and he thanked me for that. But at the time that I had done that, shortly thereafter, I went off to graduate school to study applied physics. And, you know, I just felt that some of the theory of that was not yet well supported. it appealed to statistical electrodynamics or something like that. And professors at Johns Hopkins, one in particular, wasn't very enthused about that approach. And so, there's just various things with that I was concerned about, and I moved on. I started to look at Reginald Cahill's work, his interferometry work, and I showed off my my attempt at rebuilding his interferometer a couple shows ago. And I'm hoping that if I go into a PhD program, the principal investigator, who might be my thesis advisor, he works in optics, and I might be able to get him interested in helping me get my interferometer to work, and to see if we could duplicate Cahill's experiments, which will show the existence of an ether. So now people say, well, that was disproven by Michelson-Morely. It turns out the Michelson-Morely experiment that had air in it actually may have detected absolute motion. And the way it can be better modified to detect absolute motion is to put not just air, but something that is a refractive media, like, say, glass. Water is refractive, and we're going to talk about that today. So this session tonight is really just maybe just showing what it's like to try to investigate and maybe even hit dead ends, because most of the investigations of young Earth creationist researchers will be like going on a field trip. There's no guarantee you're going to find anything, but you have to have your due diligence to look. So today we're just going to go, I think it'd be helpful, I wanted to really read through a particular Wikipedia entry on the Fizeu experiments and comment on it. And maybe I hope to conference with Dr. Dennis in a few days, and then talk about how to teach special and general relativity. General relativity, this is my textbook. This is my textbook here. First course, it's by Bernard Schutz, and I haven't looked at that in like 11 years, and it is a challenging book. But there might be parts of it that we could share, that I could share, and we can go through it and some of the concepts. Some of the stuff with time dilation I think would be very interesting, and I have there are ways to get the same answer, but then to look at it differently. For example, in Einstein, the Einsteinian version is as your velocity increase, the time is different in the reference frame of like your spaceship that's moving along. An alternative view that'll actually get you the same computational results is that simply the faster you go, your clocks just slow down, but time is absolute. And the idea of an absolute clock is very satisfying to those who like quantum mechanics, and most people will put quantum mechanics as having priority over general relativity. And Sabine Hassenfelder on the back reaction channel had pointed out general relativity can't be quite right. It can't be as a matter of principle because it conflicts with quantum mechanics. So general relativity has all time is relative. In quantum mechanics, you want an absolute clock. You can look at the Wikipedia entry on the time problem. So I've sort of known about that. It was kind of in my book, and then also I'd seen it, and then now that Sabine Hassenfelder is just pointing that out, that's really kind of just wonderful, because then we can, all right, it's like we all have the same goal now. We want an absolute clock, and we want to see if we can amend general relativity to have an absolute clock. And I'm just suggesting that there might be a way to just use the same equations of special relativity and assume an absolute clock, but then say that the clocks that are in motion just simply slow down. Not that time slows down, but there is still, the clock slows down. And I'm going to review this with Dr. Dennis. But if you get the same results, then maybe you don't have to assume then that all time is relative. You can thus reconcile it with quantum mechanics that wants an absolute clock. So I kind of like that solution. And as from a pragmatist standpoint, if all the viewpoints give you the same experimental results, then you can't favor really one over the other. So if you're able to execute the Heffield-Keating experiment assuming absolute clocks, and just assuming that moving clocks just slow down because they're moving through the ether, but you get the same results, you still use Einstein's equations, Lorentz transforms. And Lorentz, by the way, was before Einstein, at least in terms of deducing kind of what eventually looked like time dilation. Then this should be, this should be an interesting way to conceptualize it, and I think it can actually be taught better. The twin paradox actually would work better if you assume absolute clocks, where you have two twins, one on, and one guy launches in a really fast rocket ship and comes back. The guy who is in the fast rocket ship and comes back will have aged a lot less than the guy, his twin, on Earth. And that seems to suggest an absolute clock. The reason that you can do that is one of the guys experienced a lot of acceleration and then deceleration. It's clear that, it lends credence to the idea one guy really is moving faster than the other because he was experiencing acceleration over time. And for for the formalists out there, the integral of acceleration with respect to time is equal to velocity. So so there is definitely a change. In one frame, it would seem to be would be a better reference than the other, the one that has always never been accelerated. The frame that had to experience acceleration to get to that velocity, then we'll have the one that might be time dilated, assuming it started from a kind of a rest position. And then we have the concept of the rest electron mass, and that suggests if you're assuming rest masses of subatomic particles, that suggests that those hypothetically those things would have that mass when they are at rest relative to some absolute reference frame. So I'm going to run those ideas by Dr. Dennis and others. And as I said, Dr. Dennis is published in the Physical Review Letters. He's a member of the American Physical Society. Anyone who has published on general relativity in the Physical Review journals, you're top tier. You've earned the right to speak authoritatively. And the amazing thing is he was able to do that, publish in the secular world, and also be a young earth creationist. So he is elite among the young earth creationists in that sense. So I'm just looking through the side chat. Greetings, Brain Bug. Leophilius, greetings. Germania, greetings. And let me see if I can unpin. All right. So as I said, this might be just at this point, I've kind of gone on my tirade. And I'm just going to go over the Fizeu experiment. It's interesting, and we'll go through some small calculations to see if I can actually do them. And you can actually, this one actually does measure the one-way speed of light. You can actually, it's variable. This one is a variable speed of light because you're not varying speed of light in a vacuum. You can vary it in a refracted media. And so it's just interesting. And let's just go there now. Let's see if I have my Fizeu. Did I lose it? Oh boy. I'm afraid I lost my Fizzy experiment. I may have blown away my Fizzy. Where's my poor Fizzy experiment? This one. Okay, apologies to everybody. Let me just try to get this going. I thought I had this all set up, but Murphy's Law, the worst possible time. Something doesn't work. All right, Fizzy experiment. So this experiment was done in 1851 with no modern electronics, no cesium beam atomic clocks, no lasers, no electronics. I mean, how did the guy do this? It's just unbelievable. So I'm just going to read this, and I wanted to say, part of the reason I do this, it's just fun hanging out with you guys. It gives me a chance to provide like a little space where you could text each other in the group side chat. And so if you ignore the lecture and just want to chat away, just behave yourselves, guys. Be nice to each other. Just go ahead, and I'm delighted to just provide a venue and a room where you all can hang out and just to enjoy one another's company. So, the Fizeu experiment. This article is about the experiment to measure the relative speed of light in a moving medium. For Fizeu experiment to measure the absolute speed of light, see Fizeu Foucault apparatus. The Fizeu experiment was carried out by Hippolyte Fizeu in 1851 to measure the relative speeds of light in moving water. And there's a picture of the interferometer there, the apparatus. Fizeu used a special interferometer arrangement to measure the effect of movement of a medium upon the speed of light. According to the theories prevailing at the time, light traveling through a moving medium would be dragged along by the medium, so that the measured speed of light would be a simple sum of its speed through the medium plus the speed of the medium. Fizeu indeed detected a dragging effect, but the magnitude of the effect that he observed was far lower than he expected. When he repeated the experiment with air in place of water, he observed no effect. His results were seemingly supported by the partial ether drag hypothesis of Fresnel, a situation that was disconcerting to most physicists. Over a half-century passed before a satisfactory explanation of Fizeu's unexpected measurements was developed with the advent of Einstein's theory of special relativity. Einstein later pointed out the importance of the experiment for special relativity, in which it corresponds to the relativistic velocity addition formula when restricted to small velocities. Although it is referred to as the Fizeu experiment, Fizeu is an active experimenter who carried out a wide variety of different experiments involving measuring the speed of light in various situations. So there are multiple Fizeu experiments, but I guess this is the one that's really famous. So I'm just going to describe this just a little bit. What he was able to do is we have water moving here from right to left and water down here moving from left to right. the sunlight is moving left to right. So when the sunlight goes through the water that's moving, it's faster. So you have faster speed of light going in this direction and slower speed of light going in this direction because the water is moving in a different, the water is moving against the sunlight. Now, the people who are familiar with relativity will say, oh, that doesn't make sense. This is happening with light going through water, which is a refractive media. This is not the same as what would happen in a vacuum. All right. So I just wanted to, and in fact, when I studied special and general relativity, we never dealt with light moving through refractive media. We just sort of knew, okay, it moves through glass. It's gonna, it's not quite the speed of light in a vacuum. So the maximum speed limit is assumed to be the speed of light in a vacuum. When it's going through a material like glass or water, it's going to be slower than that speed limit. And that allows you to change the speed of light by simply moving the speed of light going through a medium, not the speed of light through a vacuum, but through a medium, you could change the speed of light by moving it. And so this is what Fizeu's experiment was. I just think it's really interesting, and it actually does raise some issues about how we measure time, because there's also the Hoke experiment, which I might mention in passing. So, so I call this the lab rest frame. So you have the laboratory here, and it's stationary, but the water's moving inside the laboratory. So within the lab rest frame, we're able to measure that the speed of light is going faster from point M to this one. I don't know why it says BS. From left to right is faster than from right to left this way. And people would rightly wonder, it's like, how did this guy measure it? He doesn't have a precise atomic clock. He uses what they call interference patterns, and I'm not that familiar with actually the theory of interferometers. I built one, but I don't understand the theory. I just took someone else's schematic, which is by Reginald Cahill. He figured out how to build the interferometer. I just put the parts. Okay, I was just like a technician when I built my rendition of the interferometer. But Michelson, Morely, and others, you can barely see it here. There's this you could see it looks like these lines here. He analyzes the patterns of the lines to tell if it's faster or slower. So when he stops the water movement, he'll get one pattern of lines. When he starts it up, he'll start to see the lines change, what they call fringe shifts. And then he's able to estimate then changes in velocity. So even if he didn't know the absolute velocity of light, he could still determine the effect of moving water to change the measured speed of light. In a non-vacuum, I have to emphasize that. You can change it if you're dealing with a non-vacuum. In a vacuum, that's the point of contention, that it's not supposed to change in a vacuum. That is a question of interest to young Earth creationists, if the vacuum speed of light can be changed. And some proposals by like Barry Setterfield are that if we change the 0-point density, energy density, you might be able to change the velocity of light through the quantum foam. There have been some secular papers that have also suggested that. So, that's pretty much on the fringes, okay, of speculation. So, just for the sake of argument, we'll just assume that the vacuum speed of light is the maximum speed limit. That poses problems for young Earth creationists, and Philip Dennis has offered his views of how to get around that. But in any case, we'll just keep going here. So you saw earlier with the actual drawing, I presume that was Fizeu's drawing of his apparatus. And then now we have a simplified schematic of how this was done. So I'll just keep reading here. A highly simplified representation of Fizeu's 1851 experiment is presented in Figure 2. Incoming light is split into two beams by a beam splitter and passed through two columns of water flowing in opposite directions. The two beams are then recombined to form an interference pattern that can be interpreted by an observer. The simplified arrangement illustrated in Figure 2 would have required the use of monochromatic light, which would have enabled only dim fringes. Because of white light's short coherence length, and I'm sorry I don't know what that is, use of white light would have required matching up the optical paths to an impractical degree of precision, and the apparatus would have been extremely sensitive to vibration, motion shifts, and temperature effects. Yeah, I know that. I built an interferometer, and it was extremely sensitive to vibration, motion shifts, and temperature effects. In fact, I showed you all my disassembled interferometer, and that thing wouldn't stabilize. And I called up the designer, Professor Cahill in Australia. I emailed him, and he was very kind to write me back. He said, "Oh, just put it inside a, what do you call it? A cooler. Put it inside a cooler and dump some ice in it." And it started to stabilize, but I think I needed barometric. I needed kind of barometric control. I needed to now make it also an isobaric chamber. But I tell you, it was sensitive to, if I just kind of touch the apparatus, you'd see the interferometer just go crazy. But that interferometer was meant to do what Michelson attempted to do, which was measure absolute motion of the Earth through space. And I actually don't think it's that outrageous now that, as I said, if you can keep track of your acceleration, it seems to me you should be able to, with certain accelerometers, you should be able to estimate whether you're actually, how you're moving through space. It's kind of complicated, and it does involve actually measuring time dilation of your little probes. So that's one of the ideas I'm going to be running by Dr. Dennis, if at least in terms of a thought experiment, it is feasible to actually make a speedometer, an internal speedometer. Now, obviously, when you're seeing a spacecraft fly before you and you're in some sort of what we call quote-unquote lab frame, you can definitely tell it's moving. But, if you're out there in interstellar space, can you tell me that you're actually moving that much? Unless you have a reference point. And so kind of the goal is to see if, just like hypothetically in principle, can you build a speedometer without actually having to look outside? So that's kind of a project, and part of it actually is to actually teach relativity. If this thing is correct, it's actually a nice way to teach relativity. And so the interferometer I built was meant to try to do the Michelson-Morely interferometer, but using glass instead of air. It turns out the first Michelson-Morely interferometer, it actually had I have a paper that showed it may have actually detected something because it had air as a refractive medium. And some people have tried to rebuild the interferometer just using dielectrics, like glass that actually that might be able to detect the ether. So this is why the Fizzy experiment is interesting. You could see it has some interesting effects. You're able to change the speed of light by just moving the water. And that may have some implications. So the interferometer I built, which was actually designed by Professor Cahill, was deliberately using refractive media and using what he calls, there's like what they call a Fresnel drag phenomenon, which is ether-like. So I'll just go back to the article. Anyway, Otherwise I'll never get through it. The simplified arrangement, okay, so I was just saying the interferometers have sensitive vibration, motion shifts, and temperature effects. On the other hand, Fizeu's actual apparatus, illustrated in figure 3 and 4, was set up as a common path interferometer. This guaranteed that the opposite beams would pass through equivalent paths, so that the fringes readily formed even when using the sun as a light source. And Fizeu wrote, the double transit of the light was for the purpose of augmenting the distance traversed in the medium in motion, and further to compensate entirely any accidental difference of temperature or pressure between the two tubes, from which might result a displacement of the fringes, which would be mingled with the displacement which the motion alone would produce, and thus had rendered the observation of it uncertain. So he's a very good experimentalist. God bless him. Oh, Mr. Jetty's here. He says, stellar aberration shows us that the speed of light is the same in all directions. So this is I'm presuming this is Fizeu's own drawing here of his experiment. This is incredible. I mean, no electronics, no laser lights, no atomic clocks, and he's able to make these measurements. A light ray emanating from the source S is reflected by a beam splitter G and is collimated into parallel beams by lens L. I'm looking at this diagram. Okay, so he's saying light emanating from source S is reflected by beam splitter G and is collimated into parallel beams by lens L. So light goes in here, it gets the beam split, it goes through the lens L here, and then now it has a straight path. Okay. After passing the slits O1 and O2, the two rays of light travel through the tubes A1 and A2. Through which water is streaming back and forth as shown by the arrows. The rays reflect off the mirror M at the focus of the lens L prime, so that one ray always propagates in the same direction as the water stream, and the other ray opposite the direction of the water stream. After passing back and forth through the tubes, both rays unite at S. So I guess it's going to come back through here, and it gets united here, where they produce interference fringes that can be visualized through the illustrated eyepiece. The interference pattern can be analyzed to determine the speed of light traveling along each leg of the tube. I think that's really cool. So now it says, assume that the water flows in pipes with speed v. According to the non-relativistic theory of the luminiferous ether, the speed of light should be increased when dragged along by the water and decreased when overcoming the resistance of the water. I mean, this is kind of like, flying an airplane against or with the wind. So they're just treating the ether kind of like air. The overall speed of a beam of light should be a simple additive sum of its speed through the water plus the speed of the water. That is, if n is the index of refraction, so that c over n is the velocity of light in stationary water, then the predicted speed of light w in one arm would be w plus, that's c over n plus v, and the predicted speed in the other arm would be with w minus c over n minus v. Hence, the light traveling against the flow of water should be slower than water traveling with the flow of water. Okay, I'm going to just do a calculation here just to help. Let me see if I could bring this up. This could be a disaster here. Let me see if I could find this, if you'll indulge me a little bit. Let me see if I could find this. I'm going to do something risky here. This may totally blow up on me. Let's see. Okay, index of refraction of water. So I'm just going to show some things here just to, maybe help. I hope it'll help more than confuse. It's always risky to try to do something on the fly like this. So let me see. I'm just going to show another browser window here. And it's showing the wrong window. Try again. It's not finding it. Okay, I'm just going to quit for now. It's obviously having problems finding this. I was trying to find the refractive index of water. It's 1 point. Let's see if I can get it. It's 1.33. So I'm just going to, sorry about that noise. So that's what we call N. N is 1.333. That's N for water. So I'm going to go back to the Fizzy page here. So if N is the index of refraction of water, and that N for water is 1.333, and they're showing what the value of the speed should be according to Fresnel theory, and it turned out to be wrong. When they actually measured it, when Fizeu measured it, it says here, the interference pattern between the two beams when the light is recombined at the observer depends on the transit times over the two paths and can be used to calculate the speed of light as a function of the speed of the water. Fizeu found that the speed was c over n, c being the speed of light, over n times v quantity 1 minus n squared. In other words, light appeared to be dragged by the water, but the magnitude of the dragging was much lower than expected. Okay, so this is going to be a little bit dangerous. Let's see, what's the speed of light in meters per second? 10 to the 8th. Let's see what it is. 3 times 10 to the 8 meters per second. It's roughly, it's not exactly that, but that's close enough for our purposes. So what I'm going to do is I'm just going to calculate this if we assume water is moving at 1 meter per second, which is booking, I think. But so I'm just going to try to do that now. So speed of light, meters per second, is what, 3 times 10 to the 8th? See if I can get this a little bigger, just so. And for water, speed of water, I'm just going to assume about 1 meter per second. I like the number 1. And oh, Leo, thank you. I'll use Leo's figure. 299,792,458. Which unfortunately it rounded it off. Let me just see if I could format that. Let me try to format it. I'll get it out of scientific notation here. It's going to take forever to get the format window up. And okay, there you go. So n squared, I'm just going to multiply n by itself. So that's n squared. C over n. So we take C divided by n, and that's meters per second. Well, that's not, I'll do it better. So the speed, meters per second. Let me just cut down the number of decimal places here. So we could see then this speed of light in the vacuum and then speed of light through the water. The speed of light through the water is lower. And then let's go back to the Fizeu. So we had the velocity. So 1 minus 1 over n squared. And so this is how I actually do some of these calculations. If I have access to a spreadsheet, it's great. So 1, so this is 1 over n squared. So 1 divided by n squared. And what's the other term I need? 1 minus 1 over n squared. So I'm just kind of building this up. 1 minus 1 over n squared. So 1 minus 1 over n squared. And then we take the velocity of that time, velocity of water, 1 minus 1 over n squared. Let's see. V is equal to the speed of water. So I'm just going to multiply this. Okay, so we have Cn. We multiply V, which is this, times this. And hopefully I didn't totally just mess this up. So V times 1 minus 1 over n squared. And so I got this part here, and I just need to add C over n. So let me try to do that now. And this will be the, oops. So C over n plus V times 1 minus 1 over n squared. And the final value is that plus that. Oh my goodness. You could see here that Fizeu was able to, if you assumed only just a very like 1 meter per second of water movement, you're getting just a really small percentage change, and that's what his interferometer could do. So let me just change this to like 10 meters a second, and you can see he's able to. You're able to change the speed of light through this apparatus by just changing the speed of the water. So now let's say the water's moving in the opposite direction. You get changes there. So what I was just trying to illustrate is I really just, for my peace of mind, I wanted to get a feel for how little of a change he's able to get in detecting the speed of light. I'm just going to do a quick calculation here. With the spreadsheet. This is like, okay, if the water's moving at 10 meters a second, and that's fast, he's able to get a 2.5% change. Let me just verify that. That seems incredible. No, I don't think that's right. That doesn't look right. Hang on, let me do this again. Yeah, I got a better number. It is teeny tiny. It's on the order of, I think, like 1/1,000,000 of a percent. It's tiny. It's really tiny. So let's just go back to the Fizeu thing, and I'm just going to try to finish it up here. I really didn't have anything more than that, you know, until I talked to Dr. Dennis. So I'll just read this. Okay, so it says, in other words, it appeared to be dragged by the water. That is, light appeared to be dragged by the water, but the magnitude of the dragging was much lower than expected. The Fizzy experiment forced physicists to accept the empirical validity of an old, theoretically unsatisfactory theory of Augustin Jean Fresnel that had been invoked to explain an 1810 experiment by Arago, namely that a medium moving through the stationary ether drags light propagating through it with only a fraction of the medium's speed, with a dragging coefficient given by 1 minus 1 over n squared. So just pointing this out, you have the 1 minus 1 over n squared here, and you have it here. So this is the Fresnel drag coefficient right there. So you take the velocity of water, or the refractive media, and you multiply it by the Fresnel drag coefficient. And in the interferometer that I was trying to reconstruct by Cahill, I think it had a Fresnel drag term in it. So I'm just going to move on here. Okay, so in 1895, Hendrik Lorentz predicted the existence of an extra term due to dispersion. That's his formula there. You still see the Fresnel drag coefficient here, but then this extra term, the dispersion term. Since the medium is flowing towards or away from the observer, the light traveling through the medium is Doppler shifted, and the refractive index used in the formula has to be that appropriate to the Doppler shifted wavelength. Zeeman verified the existence of Lorentz dispersion term in 1915. It turned out later that Fresnel dragging coefficient is indeed in accordance with the relativistic velocity addition formula. Repetitions. Albert Michelson and Edward W. Morely, 1886, repeated Fizeu's experiment with improved accuracy, addressing several concerns with Fizeu's original experiment. Deformation of the optical components in Fizeu's apparatus could cause artifactual fringe displacement. Observations were rushed since the pressurized flow of water lasted only a short time. The laminar flow profile of the water flowing through Fizeu's small diameter tubes meant that only their central positions were available, resulting in faint fringes. There were uncertainties in Fizeu's determination of flow rate across the diameter of the tubes. Michelson redesigned Fizeu's apparatus with larger diameter tubes and a larger reservoir, providing 3 minutes of steady water flow. His common path interferometer design provided automatic compensation of path length so that white light fringes were visible at once as soon as the optical elements were aligned. Topologically, the light was that of a Sagnac interferometer with an even number of reflections in each light path. Oh boy, that's another topic, Sagnac interferometers. Dr. Dennis and I'm hoping to run by him some of teaching materials regarding the Sagnac interferometer. The Sagnac interferometer can actually be used as a navigation device. So basically you have like light spinning. I might show that. I might have to do a specific show on the Sagnac interferometer. I will mention this now, because this is starting to get just into pure teaching, not necessarily young Earth creationism, or, I mean, this will form the basis of understanding young Earth creationist problems and possible solutions. It's kind of not like the bottom line stuff. I do have an academic channel I may be trying to exercise where I'll be providing these teaching materials, and just so that I don't make this main channel just like one long physics classroom, or a chemistry classroom, because that's how it could end up if I keep doing this. So that's motivation to try to get some of this on the academic channel. And if you'll just indulge me one moment here. Dr. Dennis has told me he just wrote me, so we're on for tomorrow. So I'm excited. I get to talk to Dr. Dennis, and he's going to help me relearn relativity, which is so much. It's been 11 years, and I was just looking through some of this notation, my head was spinning. I mean, I had to go on to do biology for a while, so now it's kind of good to get back into physics. So let's go back to, we'll just kind of wrap up here. So we talked about the Sagnac interferometer. This offered extremely stable fringes that were, to first order, completely insensitive to any movement of its optical components. The stability was such that it was possible for him to insert a glass plate at H, or even to hold a lighted match in the path without displacing the center of the fringe system. Using this apparatus, Michelson-Morely were able to completely confirm Fizeu's results, not just in water, but also in air. And so, if the name Michelson sounds familiar, Michelson went on to win the Nobel Prize for his work on trying to detect, or failure thereof, to detect the ether. So it's really kind of one of the ironies of Michelson's story. He tried to detect the ether and felt he failed. He accepted the Nobel Prize, but for a failure. Incredible story. Still a great contribution to the body of science. Michelson was among the first to make the measurements of the speed of light very, very precisely. And Barry Setterfield, a young Earth creationist, has studied the original measurements and argued that Michelson's measurement indicates that light has been slowing down. And I'm just like, well, okay, I'm undecided on whether we've actually measured that or whether that was experimental error. So, these are things young Earth creationists have to deal with, because we have an abundance of speculation, but not enough physical measurements that seem to favor our viewpoint. I remain hopeful, though. So anyway, why don't I wrap this up with the last paragraph. Since then, many experiments have been conducted measuring such dragging coefficients in a diversity of materials of differing refractive index, often in combination with the Sagnac effect. For instance, in experiments using ring lasers together with rotating disks, or in neutron interferometric experiments. Also, a transverse dragging effect was observed when the medium is moving at right angles to the direction of the incident light. So I think that's it. We've had an hour and 12-minute show. It's given me a chance to look through this and also create a spreadsheet to kind of just give a feel for the calculations. There it was in 1851. This guy was getting something that could detect changes, variations in the speed of light on the order of 1/1,000,000 of a percent. That's just insane. That, you know, an apparatus like that could be that precise. So it's just been fun hanging out with you guys again. I don't know that I've been able to advance any evidence for the Christian faith in today's show, but it's actually pretty rare that we can find things. So I gave you kind of a glimpse of sometimes what it's like to do research in this area. Most of the time you're just going to draw up blanks. But hopefully in the process we're edified and we advance our own personal knowledge that could be filed away for future use. So with that, I dedicate this stream to the glory and honor of our Lord and Savior Jesus Christ. I'd like to express sympathies for anyone who's suffering. I get emails, and unless I confirm that I have the liberty to share it on the channel, I try to keep it private. But I'm aware of the pain that's out there. And I respect your all's privacy, and you all are in my thoughts and prayers. You can be in prayer for me, and yeah, I'm looking through the chat here to see if there's anything else. So with that, I'll just end with my usual airplane and poetry. Take care. God bless you, and the grace of the Lord Jesus Christ be with you.
I have slept the surly bonds of earth and danced the skies on laughter-silvered wings. Sunward I've climbed and joined the tumbling mirth of sun-split clouds and done 100 things you have not dreamed of. Wheeled and soared and swung high in the sunlit silence. Hovering there, I've chased the shouting wind along and flung my eager craft through footless halls of air. Up, up the long, delirious, burning blue, I've topped the windswept heights with easy grace, when never lark nor even eagle flew. And while with silent, lifting mind, I've trod the high, untrespassed sanctity of space, put out my hand and touched the face of God.